and now we will continue in our webinar, and this is my part because I'm the field application specialist in VIAVI for the same area as Emiliano, so EMEA and LATAM, and we are also working with Emiliano and Karin on the MicroNIR educational program, and this can be one of the steps of our big educational program that we are trying to develop in VIAVI for the MicroNIR products. I'm a researcher, so I can do this work thanks to a collaboration between VIAVI and my research group. I have a postdoc fellowship in the group of analytical chemistry and chemometrics in Italy. I'm based in Genova, and I basically work with NIR spectroscopy, but from the chemometric point of view. What is chemometrics is just the statistic, the numbers that we need to understand the information that is behind the spectra. What we are doing today is a real case study. So I'm at home and you know, but I tried to recreate an example like in the lab. So I have with me some powder of paracetamol, of magnesium citrate, and of sucrose. And what we will do together, I have my MicroNIR with me, and we will acquire the data of the ingredient. We'll create the model for the differentiation of this free ingredient, and then we will synchronize the MicroNIR tablet app, that is something that is dedicated for the MicroNIR OnSite-W, and we will validate our method that we just created as directly in the field, as in the warehouse, like Emiliano was explaining you. So I have with me one MicroNIR OnSite-W, my reference standard, my personal computer in which I installed the MicroNIR Pro software version 3.1 and the MicroNIR tablet app. So the classification of different raw materials, so the procedure of the raw material identification is based on an algorithm that is called spectral match value. And this algorithm will follow 4 different steps. The first one is the training phase. So we have to learn, we have to teach, in this case, to our device, and the device has to learn how is the spectral signature of each of the ingredients that we want to characterize. Once we have created this group of samples, group of spectra that we call library, we have the step of class definition. It means that we have to define a suitable threshold that define a specific class. So we define boundaries for each of the 3 ingredients that I have in front of me on the table. Then I need to check for ambiguities, because maybe I have to correct a little bit my boundaries and not to cross-correlate, not to have overlapping between the ingredient that I want to identify. And finally, I have my classification model. When I have built my classification model, I can directly acquire the spectra of unknown sample and assign them to a specific class thanks to the mathematical model that I've just created. What is inside the SMV, spectral match value algorithm? Is a really simple algorithm that is based on correlation. It means that I have 2 spectra. Consider that one spectra is the fingerprint of a specific ingredient. I have the specific spectra, and I want to see point by point, wavelength by wavelength, the correlation that I have between the spectra, or the spectrum of magnesium citrate, the spectrum of paracetamol, and the spectrum of sucrose. But of course, I don't have just a correlation between classes, but I have also correlation between samples. So it's really crucial to do a really important sampling, a really focused sampling, a representative sampling of each ingredient that I want to model. So it's not enough to acquire one spectrum of paracetamol and says, okay, I have evaluated all the possible paracetamol that I want to analyze. I need some spectra. I need to create a library, I don't know, 15 spectra for each different material. And then I can verify if the differences inside each single class are bigger or lower than the differences with another ingredient and with unknown sample. So this is a really, really simple correlation. But the math is too much for today, so let's start the hands-on session. So I will open my MicroNIR Pro software, and here I'm in the developer space. I don't want to enter in all the environment of the software, but of course with MicroNIR Pro software you are able to acquire, import, export data, create model, pass model to someone else, use the model that you created for other samples, and so on, like a simple multivariate analytical package and acquisition package. In particular, we will focus on the data analysis because I already acquired the spectra, not to waste time with you. This morning, I acquired the spectra for my magnesium citrate, my paracetamol, and my sucrose. So I'm ready to use this spectra for creating the libraries. So I open the spectral match value. This is the graphical user interface of the software. It's really easy. We need to create a new method that we will call raw material identification web for webinar, and I have to add the libraries. Here I have lots of spectra that I have acquired, but today we are interested in paracetamol, magnesium citrate, and sucrose. These are the free library that I want to create. So inside each single folder, I have 6 spectra for each material that I want to model. I click OK, and here you can see the 6 spectra of the paracetamol, the 6 for the magnesium citrate, and the 6 for the sucrose. One advantage that I have with the spectral match value implemented in the MicroNIR Pro software is that I can apply preprocessing dedicated to each of the libraries. So I can say, okay, for paracetamol, I want to apply SNV and first derivative. I apply, and here you have the profiles that are represented in preprocessed data after SNV and first derivative. And then I can directly calculate the library. So clicking calculate, I'm doing the boundaries that include the 6 spectra. And I see that I have 2 spectra out of the boundaries. So I have to correct my boundaries, that is the red line, to include all the spectra that are representing the paracetamol. In this way, I'm said, this is the correlation inside the class. This is the correlation between spectra of paracetamol. Everything that is on the lower part of the red line is not considered as paracetamol. So I have my library and I define my boundaries, my threshold. Then I can move to the magnesium citrate and I can do again SNV and first derivative. I will keep it simple, but you can of course apply all the data preprocessing that you need. And again, I can see my preprocessed data. Then I go down, I calculate my model, and again, you can see that I have 2 dots that are in the wrong part of the boundary because the boundary is fixed. It's on default and we have to modify it to include all the dots. Perfect. Now all the dots are included. I define my boundaries and I can move to the last one library, that is the sucrose. For a sake of simplicity, I will continue with the same data preprocessing, but we can change it and also change the wavelength range in which you want to work. And I calculate again, and you can see that maybe the sucrose that I have on my table was similar one to the other, so the spectra were really similar, and I don't need to change my default threshold. Perfect. I calculate the library for the 3 ingredients, and you can see the green tick here, and I'm ready to look at the entire library. I want to see the library of the 3 ingredients, and this is the table for the cross correlation. So the color will help me in understand this table. I can see that the cross correlation between one ingredient and itself is equal to 1 per definition. So all the diagonal of this matrix is 1. And it's important to see that the number that are here are lower than the threshold that I defined. It means that the differences between the classes are higher than the difference inside a single class. So I'm ready to use this method, this spectral match value that I created for a practical application. So I have to save it. We remember that was called RMID web, and I'm going to save it. Perfect, I have it. Now I have to use it inside a method, because we have to remember that the algorithm, the classification in this case, is just one step of the NIR procedure. We need to acquire a proper sample, a proper white standard, a proper dark spectra, and so we have to include this model inside a method. We can do this simply in the software. We go in the setup area and we create a instrument and method configuration, a new method. We will call it RMID web, as we said before, but I'm not changing the model. Pay attention, this is a method that includes the model. In the method, I can also change the spectrometer configuration, but it's something that I don't want to touch today because we will keep everything as default configuration. And here I have the workflow. The workflow is a really important function that we have because we can customize the workflow of acquisition and processing as we need and as we want. We want to acquire a simple dark scan, so I don't add any action. The same for the reference scan, but I don't want to see the spectrum. I want to see the result of my model. So I have to upload here my model. The model is a spectral match value model. And you remember that the name was RMID web. This is the model. You can see all my threshold, the ingredients that I've measured, and so on. I click OK. And I save my model. Here I have other interesting opportunities, that is create a report, or export my data, or add my logo in the report. These are all fancy functions that I have in the system, but I think that we will stay focused on the core. So in this way, I created the method RMID for the webinar. I come back. Do you want to change or continue editing? Yes, I want to save, and that's okay. Now I want to assign this method to a specific user. And in this case, I want to assign the method to the tablet app. This is the tablet app. What is the tablet app? It's a really simple user interface that we can see together. and the analyst, the person that is doing the acquisition, is not able to enter in all this procedure that we made together. This is a closed environment that just give you the answer without touching the method or the models that are behind. So this is really crucial for RMID application, because for using the tablet app, you don't need to know even what is an NIR spectrum. So let's try to synchronize our method that we just created with the tablet app. So I'm the super administrator, so I can do this, and I want to assign the RMID web method to the tablet app. I click on synchronize, and I want to do this on the local host because I want to use the tablet app on the same computer on which I develop my method. But I can also configure and synchronize this method on the network for being used on another device. Let's speak about a tablet that I have in the warehouse and the computer on which I have the software for developing the algorithm is in the lab. I can do this, but I'm at home, so I have to use the same computer. And I click OK. The method was synchronized, so now I can close the MicroNIR Pro software and use the same password, the same credential that I have in the other software for entering this one. Now it's connecting to my device. And here I have a list of methods that I've created. And the one that we want to use is the RMID web. So what I'm doing now you have to think about 3 different cups in which I have magnesium citrate, paracetamol, and sucrose. I have here my device, and I have the reference R99 Spectral that I want to use to normalize my device. So I have just to recall the RMID web method, and I have to give the name of the sample that I'm doing. These are the tests for the webinar. And now the tablet app tell me, place your device onto the reference, and this is what I'm doing now, and click the button. I click, and you can see that dark and reference scan are in progress. Done. Then the interface tells me, Cristina, take the cup and put the cup with the first component in front of your sensor. I'm taking the cup with the magnesium. So I place here, I click. Wow, yes, this is what I want. And now I take the paracetamol. Sorry, I moved the cup. Oh, I am not acquiring properly. No, so let's try to change. I think that it takes humidity while Emiliano was speaking. So let's start with the sucrose. Okay, so yeah. The paracetamol was a really thin powder, and I think that the humidity of the air was, let's try another time, but when I take the cup, you know, some crystal was already created. We are not in the lab, and I will try last time. No, so the paracetamol is not happy to do this trial, but you can see at the end what was my final aim. My final aim was to show you that you have a really simple chart in which you can see if the device was able to understand which was the powder that was in front of the device or not. And you can also see another table with more detailed results. For example, here with the sucrose, we can see that, look, here with the paracetamol, the sample that are red, that are the one that we were not able to assign to the class, the first match was paracetamol, but the correlation was not enough. What does it mean? And this is something that I cannot do in a more proper way, that I have just one type of paracetamol, and so my library was not enough robust to accept the variation in humidity. Of course, the best your library, so the more paracetamol you acquire, the stronger your model is. But you know that I'm at home and why I'm at home. So
and actually, Cristina, sorry to interrupt you, but
yes.
I was a question that was actually asking how many samples do you need to create a class, and this is a good answer.
Yes, this is the answer. You can do the class also with the 6 sample, like I did, but as I already answered to this question, and Emiliano know, the answer is not one number. The answer is that you have to representatively sample your ingredient. So if your ingredient, like paracetamol, is unstable in terms of humidity, the more acquisition you do, the less you are prone to have problems due to humidity. So it's not a matter of number of samples, it's a matter of representativeness. Okay, so this is more or less what I want to show you, and here you can see that we have also the spectra that are acquired. So the tablet app is not just giving you the answer, but it's acquiring the spectra if you need them for example, enlarge your library. What you can do, and what I every time suggest is, let's start with a library that have 15 samples for each ingredient. I start using my MicroNIR, and when I finish the day, I can use that spectra to increase every day my library, and the model will be more robust every day. And you can see that I can do the model in 3-4 minutes. So do it every week is not so heavy, but I can have a big improvement of my results.